2012 number 6, okay? For the BC is the sums, it's the series, Maclaurin series, okay. The function g has derivatives of all orders, great. And the Maclaurin series for g is given. There it is. Use the ratio test, determine the interval convergence Maclaurin series for g. Okay, determine the interval of convergence. So that means we also have to check the endpoints. The interval of convergence means we have to check the endpoints to see if we include them or not include them. And then the radius of convergence that doesn't require us to check the endpoints. So there we go. I'd use the ratio test. So I'm going to write down first, since this is a fraction. Actually, I can ignore the -1 part to the n. I'm going to ignore that because of my absolute values. So I'm just going to write this with an n plus 1 first on the top. So I'll just write it normally with an n plus 1. Some people might forget to put in the parentheses. That's important because then we have to distribute that 2. And then times, and then I'll flip this over and write it normally. So 2n plus 3 over x to the 2n plus 1. That's a plus. Alright, now I'll simplify this. So if I distribute, I get that, which changes to 2n plus 3, and then I'll simplify in the next step. I think that goes, so that's 2, right? And then plus 3 is 5. Get it? Very good, very good. And then 2n plus 3, and the 2n plus a 1. Okay, the next thing I'm going to do is, and usually I do this, x to the 2n times x to the 3, and I notice this is going to cancel out with that part, but I'll show that in a minute. 2n plus 5 times the 2n plus 3, and 2, oh no, it won't cancel out, that's a 2, I screwed up, right? This is supposed to be x there, so this is x x to the 2n times regular x, so this cancels out with that. Very good, and then that's an absolute value, and then this cancels out with one of those, so that becomes an x squared. So really what I have is 2n plus 3 over 2n plus 5, and times the x squared, and now I can take the limit, because the ratio test involves taking the limit of that, and ensuring that it's less than 1, and then we can plug in the endpoints afterwards. And this fraction right here goes to 2 over 2, which is 1. So really, we want to make sure this is less than 1, so we get x squared, or the absolute value of x squared, less than 1. And that actually just means x squared less than 1, because if I plug in negatives, the square takes care of it anyway, so I really don't need the absolute value. But this also means that, actually, there, that's it. Hopefully you can just see that you can plug in a -1 and a +1. The answers here would be from -1 to +1. Yeah, hopefully you can see that. If you plug those in, it will almost work. It'll be equal to 1, but now we get to check x equals -1. So I plug that into the original, this part. So I will include the -1 there. I didn't include it, remember, because of the absolute value. It would just get rid of that. So let's see. If I plugged it in, I'm not going to remember that. 2n plus 1. So I have this a sub n, and I'm summing from 0 to infinity. And now I will start to simplify. So let's see what happens. This will give me -1 to the n, and then -1 to the 2n, which goes away because if I'm squaring it, it just goes to +1, and then times -1, that's for that +1 part, over 2n plus 3. So really, what do I have? And then there's the sum. Negative 1 to the n plus 1 there. So I'll just simplify it a little bit. 2n plus 3. Perhaps this is alternating series. So n equals 0 to infinity. That's my first check that I want to do. Is this an alternating series? So, what do I have to check 3 things. A sub n will be the, I guess it would just be 1 over 2n plus 3, right? And then times that negative 1 to the n plus 1. So, yeah, so we have to check stuff for that. And then we can say 1 over 2n plus 3 is positive for n, I guess, greater than or equal to 0. I mean, that works. Great. And then 1 over 2n plus 3. What if I put in 1 over 2n plus 1? This is the next term. Is this one smaller? Of course it is. If we plug in bigger numbers for n, we multiply them by 2, yeah, the bottom is getting bigger. 2n plus 3, if we thought about this as a line, it's a line with positive slope. So the higher or the farther you go to the right, the higher y value you'll get. So this is definitely decreasing. So that's true. And then also, if we take the limit as n approaches infinity of 1 over 2n plus 3, that also goes to 0. So this converges by the alternating series test. And now we need to check x equals 1. So negative 1 works. Ooh, that was a lot. And if we check x equals 1, what am I going to get? I'm going to get this part is just 1, so I don't even need to write it. Negative 1 to the n over 2n plus 3. And I'm summing that. N equals 0 to infinity. And this is the same thing that we just looked at, except for now we have n plus 1. So this is also convergent by alternating series. And I don't have to show any work because it's the same thing, except for n plus 1. All the steps are the same. Alternating series test. So then we can say the interval of convergence is negative 1 less than or equal to x. Oh no! Or you can say it like that. So that's part A, and I think I'm going to make the rest of the plots in a different video.